Hello everyone, welcome to video 2 of my Claude series. Most developers use Claude like a black box. They send text in and get text out. That works until it doesn't. When Claude gives you inconsistent result, it loses track of earlier instruction or behave differently on long prompts. The reason is almost always something about how Claude processes information under the hood. This video will explain the mental model that you need to understand the work behind Claude. In this slide, we will try to understand what are tokens. Tokens are basically Claude's unit of everything. One token is equivalent to 4 characters. Now Spring Boot is 2 token. Typical Java method would be 80 to 150 token. Your prompt, the response and all conversation history that counts towards this token window. Now context window is the working memory. So context window consists of token. Claude Sonnet holds 200k token at once. This sounds huge, but large document, long history and big code bases that fills this context window first. Claude also keeps your latest message and latest responses. So older messages drops out quickly without warning. That is why Claude forgets earlier instructions. In this slide, we will see how the context window fills up. So there are some examples here. For a short prompt without history, if you give that prompt, Claude will approximately take 800 tokens and the other tokens will be remaining for that context window. If we have a 10-turn conversation, it will be almost like 35k tokens. And if we paste a 300 page PDF, then it would be almost 110k tokens. If we paste a large code base, it will be 190k tokens. So we should follow some rule of thumb. We should track token usage in production. We should use uses dot input underscore tokens in the API response. When we are hitting above 150k, we should start compressing the conversation history or chunking the documents. In this slide, we will understand what happens when you send a message. So first you send a message, your message arrives. All prior turns, system prompt and new message that assembled into one sequence. From your message, it goes to the tokenizer. So in tokenizer, the text gets converted to integer token IDs. From tokenizer, it goes to the transformer layer. So here every token attends to every other token in the window and where the understanding happens. Now from transformer layer, it goes to output. So output also generated token by token. There is a key insight here. So instructions which are at the start of the system prompt and end of the user message, that gets the most attention weight. Critical constraints are buried in the middle of a long prompt that gets less weight. Now we will see some of the differences between the models. So as we see here, the context window for all the models are same. The reasoning depth for Haiku is basic, whereas for Sonnet it is strong and for Opus it is deepest. Instruction following is good for Haiku, it's for Sonnet it is very precise, and for Opus it is most precise. For code quality, we would have like good code quality in Haiku, excellent in Sonnet, and then excellent in Opus. Now when to use what, right? So for Haiku, we should use it for classification, for simple extraction. For Sonnet, we should use for production workflow tool use, and for Opus, we should use for complex reasoning and analysis. The cost also varies like that. So for Haiku, per M token input output costs are less, $0.25 and $1.25. For Sonnet, it is $3 and $15. For Opus, it is $15 and $75. So for 80% of the production task, by default, Sonnet should be the right choice. We should move to Haiku if we have high volume simple task, and reach to Opus if we have something where Sonnet is getting it wrong or it is very complex.